what we judge to be the best use of AZTEC in any dApp. And then we also have $500 for the most unexpected use of AZTEC. So in the past, a lot of our APIs are very kind of financial protocol focused. And at a Path hackathon, I believe it was ETH Paris, someone made a zero-knowledge DAO out of our proofs. And so if you can come up with unexpected ways to use what we've built, well, we want to incentivize that, basically. We hope that we've built something that's quite general, and so you should be able to use it for interesting non-financial related things. So what is AZTEC? AZTEC, in a nutshell, really, is trying to be a privacy protocol that allows anyone to use privacy on public Ethereum without them having to deeply understand elliptic curve cryptography. We are aware that it's not really an easy field, and so we want to provide basically very easy to use and easy to integrate tooling for everyone to be able to transact privately on public Ethereum. That does beg the question, though, in the first place, why do we care about privacy? If you look at most of the dApps that are out there today, they don't worry too much about privacy, right? They just go ahead and have all your balances, all your transfers, all your activity public. And when we looked at that when we were building a previous product, we realized basically that while that's okay right now, it's not okay as soon as Ethereum goes into the mainstream. And to illustrate that, I want you, for those of you that are familiar with Ethereum, I won't bore you with a big intro as to how it works, but for those of you that are not, Ethereum is basically a huge transaction graph. It's basically a huge history of every transaction that has ever occurred and every input and outputs to those transactions. So if you think through kind of a pretty bog standard I go to the shop scenario, say I use public Ethereum, do I really want my local cashier to know how much I'm paid? Because if it's public Ethereum, they'll just be able to do that. They'll just be able to step through your past transactions, eventually see the transaction that was your salary given by your company or by your boss. They'll also, by the way, be able to work out who your colleagues are and how much they're paid. And that feels a bit weird to me. Do you want your boss to know which political causes you contribute to? Because that also, as soon as we do actual work on Ethereum, as soon as there's actual usage on Ethereum, that is also something that they can do. They can just work out the address that they're paying your salary into, work out every other address that has interacted with that address, and just figure out which political cause you donate to. And that also feels a bit, basically doesn't feel like where we need to be. So we landed at the conclusion when we were building something called credit mint prior to AZTEC, that privacy is really a prerequisite for any real-world use of blockchains. We want to enable users to control their private data, their transaction history, and we really don't want third parties to be able to delve into what you do from a day-to-day. So the question again is, what is AZTEC? Well, AZTEC is a toolbox of plug-and-play privacy tools, specifically zero-knowledge proofs. We are unique in the privacy sector in the fact that we allow basically different dApps that integrate with AZTEC to interoperate with each other. So, for example, if I have two zero-knowledge assets, I can trustlessly swap between them, which is a pretty big deal. That's not something that you can typically do with, for example, ZK snarks. We're extremely gas efficient, again, compared to most privacy protocols out there, where a bunch of recent work by a big consulting company, for example, prices their transactions around 3 to 8 million gas. So we're an order of magnitude less than that. And then EIP 1108, which hopefully, if everything goes to plan with Ethereum governance, which, yeah, then we'll be closer to 200,000 gas for a private transaction, which is a pretty low number when you consider that some relatively non-trivial ERC20 transfers will get into the 100Ks. And finally, another thing that we observe compared to other privacy protocols is proof construction. So zero-knowledge proof construction usually takes a long, long time. And I'm talking minutes for the basic ones. or hours for the ones that are trying to do very complex things. And we approached it from an end user's perspective, and that was just not acceptable. If you're a user in, for example, a bank or a debt fund, and you're trying to just close a deal, and suddenly your page pops up with a waiting time of 3 minutes before you can actually do your job, you're just not going to use that platform. So our proof construction is in the order of 10 milliseconds, even on phones, which we're really proud of. And that means that we think that we're the only privacy protocol on Ethereum that is actually usable. This is kind of the basic architecture of AZTEC. I won't go too deeply into this because it's quite well described in our specification. And again, I'll post these slides in Telegram afterwards. But fundamentally, you have a user-defined part, which are the ZK assets, which define a very similar, so what we've published, it's more flexible than this, but what we've published is a very similar interface to, say, ERC20s. So you have confidential transfer, you have confidential transfer from, you can approve, you can mint, you can burn, very similar to box standard tokens, except everything is in zero knowledge. All of those assets point to what we call the ACE, which is the AZTEC cryptography protocol. And that handles basically all the complex actual zero knowledge proof parts. It effectively receives a transaction from a ZK assets, decides what zero knowledge proof it needs to validate, how to validate that zero knowledge proof, and then it gives back to the ZK asset an object that we call proof outputs, which is basically a box standard Ethereum object, which tells you what state transitions you need to do, if any. It gives you addresses of recipients and addresses of senders. So if you want to add, for example, whitelisting to your ZK assets, or if you want to add time locking, you can do that independent of validating the proof. So hopefully it gives you a lot of flexibility around how you build the assets that you build or the dApps that you build. A quick note on terminology. I realize at this point in the presentation that it may have been beneficial to introduce this at the start. So sorry about that. Zero knowledge proofs are proofs basically that you know some kind of secret or the solution to a statement without revealing the secret. So the standard example is, for example, proving that some variable A plus some variable B is strictly equal to some variable C plus some variable D. And without revealing A, B, C, or D, you're able to convince a prover that you know those variables and that equality actually holds. Notes, for those of you familiar with Bitcoin, are very, very similar to UTXOs. They differ to account-based models like we have on Ethereum, for example, in the sense that they're much closer to coins and bills that you have in fiat than they are the account-based model that you have on Ethereum. So instead of, for example, having a balance of 55, and if you send some money or some ether to someone else, you suddenly have a balance of, say, 50, and that person's balance has just incremented by 5. You would actually have a pool of notes that are worth varying amounts. And when you want to send some value to someone else, you select a subset of those that represents at least as much value as you want to. Sorry, go ahead. Is that a question? Oh, sorry, I thought that was a question. So you select a subset of those note objects, and you create some new ones that are going to go to the recipients, or some can come back to you as well. Very similar to change in a traditional transaction. So it does, if you do integrate with AZTEC, or if you do build on AZTEC, those are the kinds of two big things that you need to have or an awareness of, because it does change how things are built a little bit. But they're fundamentally pretty simple concepts to work with. The actual AZTEC Toolkit, so we have basically a series of pre-built zero-knowledge proofs that you can use. We have send, which is just I'm going to send some zero-knowledge value to some other account or multiple accounts. Swap, which is basically an atomic swap between zero-knowledge assets. We have a ratio proof, so I can prove that some zero-knowledge value that the external world won't be able to tell the value of is worth some ratio of another zero value notes. That's particularly interesting if you're doing things like interest payments or dividend payments, where you can have everything about that payment completely encrypted, non-observable to the outside world, and yet still actually complete the payments and check that interest, for example, is for the correct amount. We have mint and burn, like I mentioned. They're basically exactly the same as ERC20 mint and burn. So you can create in zero knowledge. You can destroy value in zero knowledge if you are the owner of a particular asset that has that functionality enabled. And then finally, we have a series of range proofs. We have, at the moment, published in our NPM packages, we have private range proof, which is basically the idea of proving that some zero value note is worth more or less than another zero value notes without actually revealing what either note is worth. So again, an example in, for example, if you're doing KYC, proving that someone is older or younger than a particular ratio or particular age without actually having them reveal their date of birth or reveal their actual age. So yeah, this is kind of the toolkit that you have available to you to use if you integrate it with AZTEC. Like I mentioned, even though these are named particular things, we're very keen to see if you can find ways to make their naming wrong. So ETH Paris, for example, they use the ratio proof to create a voting DApp, a DAO, effectively. I want to show you just a quick demo. The purpose of this very first demo before we get into actual code is just to show you basically what an end user might see if they're interacting with the zero knowledge app. And it is effectively just a zero knowledge loan. It's an uncollateralized loan. And we're going to see the lender create the zero knowledge loan where the actual value of the loan is encrypted. We're going to see the borrower sorry, that's the wrong way around. The borrower create the loan, and the lender is actually going to fill that loan in zero knowledge. They're then going to accrue interest in zero knowledge, and then they can effectively withdraw for every block. They can withdraw certain amounts that has accrued to them, also in zero knowledge. So it should be pretty quick. Let me just. So here the borrower is just creating a loan that they want. A lender who is on the left-hand side, is that? Yeah, left-hand side, is going to see that a loan has been created right after this. And based on what kind of loan they want to submit, based on the interest, for example, they're going to request access to it. So again, this is all in zero knowledge, so without consent, you don't access it. What is on-chain, what is on Ganache in this instance, is just completely obscure to an outside observer. What is actually happening here is there's a series of zero knowledge proofs of three, actually to be exact, that have been created by this point. What actually takes time is talking to Ganache. So you'll be able to, this is all on our GitHub, you'll be able to run that locally, and basically for the end user, the addition of zero knowledge doesn't really impact user experience, which is the main thing that I wanted to convey with this demo. Here again, we're withdrawing some interest, and again, the thing that actually takes time is telling Ganache to do what we want it to do. So there's basically two ways to use AZTEC. There's one which is relatively stable. We're pre-launch. We're launching fully in September. But the first way is a LowLevel API that gives you full access to all the proofs. It gives you full access to all the notes. It gives you an interface which is a little bit more wordy, but if you want to create custom flows, that's probably the one you want to use. And we have just published an alpha of a higher level API, which comes with a browser extension, which basically abstracts away a lot of what we call note management. So if you think back to how we represent value in AZTEC, and we have this concept of some notes that are owned by a particular user, when they want to send some value across the network, they have to pick notes that actually are worth what they want to send, which can be quite a cumbersome process for dApps and dApp developers to deal with for their users. And so we're using this higher level API to basically manage that for you. The reason it comes with an extension, a browser extension, is because it has some local states, so it keeps track of the notes that a user owns. And when it comes time to actually send a transaction, it will just literally, as a dApp developer at least, you can just do .send and the amount that you want to send, and the extension and the API will manage everything else for you. I want to take you through a quick piece of code on the LowLevel API. And we're going to be building a facsimile of a private Venmo in about 100 lines of code. To do that, we're going to deploy ZK Asset, and that's the asset standard that I talked about briefly before, which looks very similar from an interface perspective to an ERC20. We're going to mint some private notes, so you'll get to see how to use the mint proof. And then we're going to send some notes to another user. The scenario we're going to be working with is Bob is taking a taxi. Sally is a very decentralized taxi driver and uses Ethereum to actually collect her fees. And we're going to use AZTEC to pay her. All of this, again, is available on our GitHub and Gitbooks docs. I'm going to post that on Telegram after this talk. So, is the text readable at the back, more or less? Okay. So this is the whole script, which takes you through that example of deploying a ZK assets, minting some notes, and actually sending a subset of those notes to Sally. There's some things that are abstracted away from you here, like, for example, where the public or if there's a public representation of an asset, where it comes from, and all these kinds of things. If you run into issues where you can't see the solution to it from code that we have available, just come talk to us. We're going to be available during the whole weekend. So the first thing that I want to do is I want to, since we're dealing in notes, and since this is the very first transaction that's going to be happening on this particular asset, I want to, as Bob, I want to create some, by the way, Bob can mint this asset, so he's kind of the central bank of his own money, which is even more decentralized. So Bob will need to create the notes that he wants to mint in order to pay Sally. So the very first thing we do locally is just use the AZTEC.js library that we've also published, and create a series of notes, or in this case, one notes, which is worth 100, which is just the public integer for that note. And to do that, we need to give the public key of Bob. But again, that's pretty. That's all relatively easy to do with our API. We then want to mint using the notes the note that we've just created. To mint in zero knowledge, we have a little bit of a complication compared to minting in public, which is you want to be able to say, you want to be able to tell as the owner of the assets how much has been minted and how much has been burned in your assets. Except everything is in zero knowledge. So all the balances that that you would usually compute using, on a public ERC20, for example, to compute your actual total burn, is all in zero knowledge. So as the asset owner, it becomes difficult to compute that sum. So we introduced two new variables on mintable contracts, which are total minted and total burned. It's confidential total minted and confidential total burned. And these are, again, AZTEC notes, which represent the value of the total that has been minted so far and the total that has burned so far. When you first deploy ZK assets, that value is going to be a zero value note. So it's going to be actually the hash of a note, which is technically worth zero, which is a constant, again, in our tooling. And the note that you're going to be replacing it with is whatever the sum of the notes that you're actually giving to other people is going to be. So when you actually do a mint operation, and we see it here, you have to create the notes, or the notes if you're minting and distributing to multiple people that are actually going to end up in end users' hands. You're going to need to get, for the very first mint, you're going to need to get what we call the zero value notes, which is just, again, AZTEC.node.create zero value notes. Should be pretty easy. And then you're going to need to create a new note, which is also worth 100, which is basically very similar to the note that you created for Bob in this case. But if you had multiple notes that was going to Bob, it would just be the sum total of those notes. You want to keep track of that note as much as possible, because on the next mint that you're going to do, this new mint counter note is the one that is actually on chain, and so it's going to be the old note in the next transaction, if that makes sense. Once you have all these variables, so you have the new total minted note, you have the zero value notes, you have the actual the sender of this transaction, and you have all the minted notes that you want to create. you simply create a mint proof, again through our local API. And once that's done, this line here, this private payment contract is our ZK asset. And we're just going to call a method on that ZK asset, which is called confidential mint. We're going to give it the proof ID, which is, again, available to you in this API, the mint data, and then we're just going to transmit that transaction. So that is just going to set our assets to having Bob having a balance of 100. Once Bob has deposited the money or has minted the money that he's going to use, we want to, well, he's going to take a taxi. Sally's taxi fee here is represented as another AZTEC note, which is worth 25. That's the fee that she's going to charge Bob. And you're going to then create what's called a joint split proof. If we go back in the presentation a tiny bit, the zero-knowledge proofs and the notes, the way you combine them in the most basic level is you basically create a zero-knowledge proof that the sum of the input to your joint split transaction, which is just a transaction to send value around, is equal to the sum of the outputs. So in this case, we're going to want to create a joint split where Bob is equal or greater to. So we're going to create a transaction where Bob is going to be using on the left-hand side of the joint split his 100 value notes. And then we are going to take the notes that we're going to try and give to Sally, which is going to be worth 25. And there's going to be a discrepancy between the left-hand side and the right-hand side, right? There's going to be, if I can do my math right, there's going to be 75. Is that right? Yes, that's right. 75 discrepancy. So we're going to also create a note which is worth 75, which basically makes that joint split balance. It makes that joint split, you're able to prove basically that joint split, the left-hand side, the sum of the left-hand side is equal to the sum of the right-hand side, and also that there has been no value creation at any point. The thing that you really want to avoid with these kinds of zero-knowledge systems is obviously that during a joint split transaction, Bob suddenly allocates, Sally 25 and allocates himself 90, thereby just creating value out of thin air. So your joint split really should be balanced. So the first thing that we do is create the fee that Bob is going to pay to Sally, create the AZTEC note worth 25. We then create the notes that Bob is going to be the change, effectively, that Bob collects after the transaction. We're going to set the proof sender again, like we did previously. We're going to send this public value is if you're actually transacting in a mix of private and public tokens, which I can talk through at the end. And then you're going to say the public owner, which again, there's no public owner in this case. And then you're going to send the proof. And at the end of the day, Bob will have paid in complete zero knowledge, so without anyone being able to observe actually what has happened, will have paid Sally, what did I forget? My total mind does not, I see. Yeah, so there's, it was trying to execute that first mint transaction twice, which is not something you want. So Bob deposits 100. Oh my God, what a... no. Sorry about that. By notes. Tom, do you have an inkling? Let me just try something. Let me get rid of the minting. I probably still need this though. I see. Sorry. Was that commented before, or did I just comment that? Okay. What I'm assuming is happening is my Ganache has some save states, and because I ran a mint once when I uncommented it first, my notes, my basic count notes have mismatched. So yeah, minted notes is not defined, but that's okay. We don't need that. Basically, Box successfully deposited 100. The fare comes to 25. Actually, we do need minted notes, which is fine. Let's do this. Well, now the notes are spent. Sorry. Basically, Ganache is keeping a cache, and I should have just run this in one go, is the lesson here. Feel free to go on our GitHub, download it, and set it up yourself if you want to explore this code. It's a pretty, if you're going to be using kind of the low-level API, it's a pretty good place to start to get something that you can hack with very quickly. We also have a higher-level API, which I can't say this enough. It is alpha. It's something that we've been working on over the past 2-3 weeks, and something that we've been working on actually this morning. So things might break. If they do, come talk to us. It's basically a way for you to not have to manage notes, not have to worry about the complexities of zero-knowledge proofs, and as a dApp developer, be able to just say, like I said, basically send some value to this other account, and for that to just work. To actually set it up, you will need to download a Chrome extension. Because this is an alpha, you're going to have to install it from source. That QR code will take you to our GitHub repo where it is. Just clone that GitHub repo, and then open your Chrome, go to Chrome //extensions, and you'll see a button that says Load Unpacked, and just select the files that you've just downloaded from GitHub, or that you've just cloned from GitHub. And that will basically give you an extension in your Chrome, which will interface with MetaMask and also inject an API in your web page, which you'll then be able to use AZTEC. To make that a bit easier to visualize and to play with, we've also created an ETH India Starter Kit, which is just a UI that will take you through the basic API for this Chrome extension. So once you've, again, that QR code takes you to the GitHub repo for the starter kit, and once you've downloaded that and followed the README instructions, you'll be able to step through a scenario that is very similar to our Sally and Bob scenario, where you have a deposit of hundreds, you have a transfer of 25, and all that through pretty high-level APIs. And actually, to take you through that, so this is what you'll see once you've set up the ETH India Starter Kit. You see that I have a little extension in the top right, which is my AZTEC extension. The very first thing that I want to do is basically log in. So I'm just going to enter my password. There's a decent chance that this might break. Again, we were coding on this about half an hour ago. Once I've logged in, I have basically an interface to the ZK asset that's deployed here. I can deposit some public ERC20 into that ZK asset. So this is just going to be, behind the scenes, going to be minting some public ERC20. We have just a very open ERC20 deployed on our local Ganache. It is then going to transfer that amount into the ZK asset, because you can have basically a public ERC20 that you use the public value and you transform it into private assets. So you can have, for example, zero-knowledge DAI very easily. And once we've gone through approval flows and actual transfers, which we have to approve, we have to sign and approve every note, which is a downside of having to rely on MetaMask at the moment. We can actually send a private transaction over to our other accounts. So this would be Sally in this case. you'll see shortly. And it is doing things. Again, most of the actual time that is being spent is on just blockchain interactions, which is, yeah, have to just deal with them for now, I think. Whilst this completes, I'll come back to it at the end. But basically, you have the very similar scenario that we had in this file, except instead of 100 lines of codes as a developer, you can now do it in 3, which is kind of why we do it in this high-level API. And hopefully, it makes playing around with AZTEC as you're exploring a lot easier. That's pretty much it. AZTEC is, like I said, a work in progress. We launched AZTEC, or we published the crypto paper in October of last year, I believe. And we've been working ever since then on making the protocol work for the use cases that, that we care about, and also making the tooling better than what it was at the start. And we're here both to see what you can build with it, but also to garner quite a lot of feedback on what works, what doesn't work, what's not intuitive as maybe a beginner developer, because I know there's quite a few people who are new to Ethereum in the room as well. And yeah, that's what we're here for. We're going to be here all weekend. We'll be posted in the main hacking room downstairs. So just come grab us. There is me, there is Leila, who is in the back. Leila, if you can wave. And there's Tom, who was supposed to be giving this talk, who is right there in the front with the AZTEC t-shirt. For the teams that actually build on top of AZTEC or use AZTEC in some way, we'll be going around tomorrow handing out t-shirts. So hit us up on Telegram if you're exploring using AZTEC, and we'll come give you a t-shirt. The only reason we don't give it out to absolutely everyone is we actually thought this was going to be a smaller workshop, and so we didn't print as many as we ought to have. We wanted to originally give everyone in the workshop some, but now it's a limited edition t-shirt, which is great. And yeah, like I said at the beginning, join our Discord server. We're pretty responsive on there. I'll take questions now, and if you have any more questions, feel free to post them on there or come to us in person. Any burning questions about privacy? About yeah, go ahead. Sorry, didn't actually hear that.
Can we build this zero knowledge proofs on top of the coin swap that we did on Kyber network?
So having things in zero knowledge, it's what I mentioned when I said the two things to keep in mind is like the zero knowledge proof aspect to AZTEC and the note aspect to AZTEC. It does change what you can and can't do on-chain a tiny bit. So if you think about how Kyber swap happens or how Uniswap swap happens, at some point there is the transmission of information on-chain that requires public variables to be accessible to everyone. So there is, in Uniswap's case, for example, there is a very big liquidity pool that everyone needs to be able to read from, and the contracts need to be able to read the total and just take some amount of that total and give it to whoever is asking. In zero knowledge, obviously, each contributor to that liquidity pool is going to be contributing zero knowledge notes that only they and the potential recipients have access to. So to do something like Kyber or Uniswap, you do need a little bit more of a trusted party that basically administrates the asset if you want to do something similar. We are working on some, I guess, further, it's quite early in terms of cryptography, but we do have things that we want to do to solve that. There might be something to talk about in a couple weeks, but I'm not allowed to talk about it right now.
Yeah. Hello. Yeah. Great talk.
Sorry, I can't see you with the lights. Oh, there you go. Yeah.
Yeah. Yeah. So from what I understood, basically what you're obfuscating is the amount that is being transferred between Alice and Bob, right? So like, is there also a way to obfuscate the sender and the receiver as well in some way? Is it even possible to do in?
So it is possible to do in a variety of ways. There's kind of the very easy ways to do that and the harder ways to do that. The current release of AZTEC doesn't have anything to do with what I'm going to talk about, but it supports it. So the very basic way to solve that issue of anonymity, of hiding the sender and the recipient, is to use a Monero-style stealth address protocol. So effectively, every address that you use is single use, and the addresses between transactions are not connected to each other, which means effectively that you don't actually have to you basically have no transaction graph to speak of. On Ethereum, obviously, it's complicated by the gas. You can have a solution to that with meta-transaction or a relayer network of some kind, but it's still complicated. Again, related to what I was just talking about, anonymity is kind of like I mentioned at the beginning, anonymity is a key part to privacy. Someone not being able to observe your transaction graph is a key part. And so we do have solutions to that problem, including the constraints of Ethereum. But those are things that we're going to be talking about probably a bit later this year.
Sure, thanks.
Any final burning questions on privacy, on AZTEC, or on the bounties themselves? Cool. Let me just do a very risky... it's still going. I think something has gone wrong with my Ganache setup in general, so I'm sorry about that. But if you run into any issues, like I said, we're going to be available during the whole weekend. So just come chat to us, and I promise we're very, very patient. We really love what we do, and we're going to try and make it as easy as possible for you folks to have privacy on Ethereum. Thank you very much. Sorry? Oh, Vitalik. Oh, yeah, I can't beat Vitalik.